Hello everyone. We are going to start this on another session on nucleophilic substitution reactions. So we have already started our discussion on nucleophilic substitution reactions. We completed one unit called SN2 reactions. So in today's case, we are going to learn another topic or another type of substitution reaction. So after nucleophilic substitution SN2 reactions, we will visit today another unit of this SN reactions, nucleophilic substitution reaction, that is SN1 reaction. So just like SN2, these are the reactions which are the concerns of tertiary alkyl halides and the nucleophiles. So basically, somehow tertiary alkyl halides, when they react with, let us say, some nucleophile, then this reaction is followed, and this reaction is basically termed as SN1 reaction. So as thus highlight that this is a reaction between tertiary butyl halide with hydroxide ion. So this, let us learn for this reaction. Already you might have learned during your schooling, but today we are going to learn this reaction for the purpose of some different aspects, that is first order nucleophilic substitution reactions. So as you can see on the screen that this is a reaction of tertiary alkyl halide and some can see the nucleophilic substance is iodide. This what will happen between tertiary butyl bromide and sodium iodide in a rapid condition, in a rapid manner, both will react with each other and the reaction will occur. In the product, as you can see that this bromide has been replaced with iodide. So generally the product form, basically it is this tertiary butyl iodide along with sodium bromide. Sodium bromide is basically termed as byproduct, because for the formation of tertiary butyl iodide, the formation of this sodium bromide is essential. Hence, this is basically termed as this sodium bromide and tertiary butyl iodide. This reaction is generally follows the first order kinetics. Reaction kinetics for this reaction is first order, because the rate of the reaction is dependent upon the concentration of this tertiary alkyl halide. If we increase the concentration of tertiary alkyl bromide, then the rate of the reaction increases. If we decrease the rate of the concentration of tertiary butyl bromide, then the rate of the reaction also decreases. That means the rate of the reaction is directly proportional to the concentration of alkyl halide. However, even if we increase or even if we decrease, there is no significance decrease or increase in the rate of reaction for sodium iodide. That means the rate of the reaction of this is independent from the rate of from the concentration of sodium iodide. That's why this reaction is termed as first order nucleophilic substitution reaction, because the rate of the reaction is dependent upon the concentration of only one substance, tertiary butyl bromide, and independent from the concentration of any other substance. This is a basic fact for this reaction. So, friends, with respect to this, These tertiary alkyl halides, which basically undergo substitution reaction mechanism, they are basically SN2 mechanism, and but sterical hindrance of the reaction is much higher in this case. Here, totally opposite. SN2 reaction was faster with tertiary. The answer is no. But here, with tertiary alkyl halide, SN2 reaction is faster. So there must be some different mode of reaction mechanism as compared to SN2. SN2 reaction was found, if you remember, that was faster with primary alkyl halide. However, SN1 reaction is faster with tertiary. There is opposite character for SN2 and SN1. SN1 reaction, which is basically termed as nucleophilic substitution unimolecular, SN1. With substitution nucleophilic unimolecular. When you are writing SN1, you have to be much careful that capital S is capital, N is also capital, but this N is little downward as compared to S. That is subscript instead of normal N. One is having equal height as that of S. So that way, this SN1 reaction is substitution nucleophilic first order. Can be also termed as you can see here, unimolecular. Thus, SN1 reaction may obey first order where rate of the reaction is directly proportional to the concentration of Rx. To remove the proportionality, this constant K is used. And another point, it also highlights that rate of the reaction is also independent from concentration of this alkyl halide. Whether we increase or we decrease, there is no effect on the rate of the reaction of alkyl halide. The order of reactivity of substrate for SN1 reaction is reversed to SN2. The tertiary, which was least in case of SN2, now that is highest in case of SN1. Methyl, which was fastest in case of SN2, now that is speeding in case of SN1. So opposite behavior of SN2 and SN1. The question comes that why such behavior is observed? What can be possible reason behind this? The reaction mechanism is totally different for this reaction as compared to the previous one. That's the only answer for this. If both have similar mechanism, then obviously जो reaction tertiary secondary के for primary के साथ faster था, the same reaction should be also fastest here. No, it's not. What is a different mode of a reaction which is highlighted here? Tertiary butyl bromide in the first step lost this bromide ion, and removal of this bromine will lead to the formation of basically this carbocation. And this carbocation, after the loss of, you can see, this carbocation, after the rapid reaction with tertiary butyl bromide, will lead to the formation of this tertiary butyl iodide. This way, this reaction can be possible. Form tertiary butyl iodide from tertiary butyl bromide. That way, this reactions is generally observed, so that all the substances can, all the tertiary butyl bromides can be converted into tertiary butyl iodides. Friends, here a new reactive species is formed, in which a substance is having specifically carbocation, where carbon is having positive charge. So basically, this is a neutral substance, and then it converts into positively charged substance. If you remember my previous sessions, so I always used to say that charge localization decreases the stability of the molecule. Charge delocalization increases the stability of the molecule. In tertiary butyl carbocation, this positive charge on carbon is localized charge, fixed charge, which is not moving from one to other place. That's why this is a localized fixed charge. And localized and fixed charge substances are unstable. So neutral, stable में से unstable होना, that is energy demanding step, requires energy. This is a slow step. But neutral positive charge, positively charged molecule में से neutral बनना, that is rapid, because energy release. We'll see the energy diagram also. So basically, this is a two-step reaction. First step involves formation of carbocation. Second step involves attack of nucleophile to form product. So this way, this reaction is involved, but this is a step which is flow step, step number 1, I shall say, because it involves reformation of carbocation. And for any reaction, the slowest step is considered as the rate determining. Flow step of the reaction is always considered as a rate determining step. So that's why in rate determining first step, only one substance is involved, and that substance is tertiary butyl carbocation or tertiary butyl bromide. Formation of tertiary butyl carbocation and tertiary butyl bromide. So with respect to this happens to be an unimolecular reaction, where rate of the reaction is dependent upon the concentration of only one substance. Tertiary butyl. Just like SN2, let us also learn other factors which can affect the rate of the reaction. In this case, three factors are known. The nature of substrate. In other words, alkyl halide. Factor number one. Factor number two, that is the ability of living group to live. You can also call it as the nature of living group. The third factor, that is nature of solvent, means what is the nature of a substance, reaction medium, the vehicle in which reaction can be carried out. What is that? Basically, these are the factors which can affect the rate of the reaction. So let us learn these factors. But here you can see this rate of the reaction is totally independent from the concentration of nucleophile. The nature of nucleophile is totally independent from this. The first and foremost factor, what is the nature of substrate? We already visited and discussed that the rate of the reaction is fast for SN1, that is faster with tertiary, secondary, primary, and methyl. Easily, an obvious question should arise to us. Why such behavior is observed? What can be the possible reason that tertiary is reacting faster than secondary, then primary, and methyl is having slowest rate? Question should arise. An answer can be given in terms of stability. If you remember my words one more time, that charge localization can destabilize the molecule, and charge delocalization and stabilize the molecule. Here, the charge on carbon is localized charge. The carbon atom, which we wish to discuss, is under tension. Just like human being, molecules have also similar tendency. Examinations are close, or let us say, you have to appear for certain evaluation or test, etc. What you will do, you will be doing the focusing on reading only. Even if your friend offered to visit, let us say, Shimla or Manali during the days of exam, you will deny your friends that no, I am doing exam, I will not be visiting such places. Because exam is a kind of environment which may create somehow tension for you, the pressure, so that you have to focus concentrated mind on the reading. Is it not? Answer is Similarly, this is a carbon which is under tension of fixation of the charge, positive charge. And carbon is, whenever it has a positive charge, it is termed as carbocation. What happens? That carbon is hanging under tension, but in a similar manner, it is having a friendship with other 3-methyl groups in case of tertiary butyl. What does this methyl group do? They tend to stabilize carbocation with positive kind of effect called inductive effect. Just like this is a carbon which is having friendship. So ये तीनों methyl group को लगता है कि our friend is in tension. Positively charged carbon needs our help. They try to support their friend. Don't worry. If you have a positive charge, we will help you to stabilize. Because we don't have any charge. So we will help you. And this help to stabilize the charge is also termed as hyperconjugation. Already carbons, these methyl carbons, they are attached with hydrogen. They are having no charge, neutral charge. This neutrally charged molecule, where this positively charged carbon was having empty vacant p orbital. That is stabilized by sp3 hybridized sigma bond. It can be sigma pi star conjugation. This is the bond which is in between carbon and hydrogen is termed as sigma bond. So the lone pair which is present in this orbital will be interacting with the vacant p orbital of carbocation. In carbocation, as we have learned in previous classes, that is sp2 hybridized. So one of the p orbital is interacting with the sigma bond. They shall try to show some overlapping interactions. And this interaction is termed as hyperconjugation. Because of this, tertiary carbocation के पास 3 friend, 3 methyl groups. Will be better stabilized. If we discuss secondary carbocation, 2 methyl group, it will be less stabilized. Primary carbocation, only 1 methyl group, it is less stabilized. And methyl carbon, which has no alkyl groups, that's why it is least stabilized. इसीलिए this reaction is faster with tertiary butyl as compared to secondary primary methyls. Now let us learn some other substances, vinyl and phenyl. So why even these reactions are more faster for SN1 when we are discussing vinyl and phenyl. Vinyl means carbon-carbon double bond. And phenyl is basically called as this phenyl substance. This one. So when we discuss basically a carbon-carbon double bond, and when it is connected with CH2, so it is termed as allyl carbon. This is allylic, when this is a which can undergo resonance. This lone pair we can move over here. So what will happen? The terminal terminal carbon will have a positive charge. Similarly, this long double bond which is present over here, when we move to the adjacent carbon, डबल बॉन्ड था वहां पे पॉजिटिव चार्ज आता है और जहाँ पे पॉजिटिव चार्ज था वहां पे डबल बॉन्ड. If this hydrogen is stabilized or substituted with another alkyl group, so secondary allylic carbocation. Benzylic carbocation is more stable. उसमें resonance होता है. Just like phenyl CH2 plus. तो यहाँ के जो lone pair है, which are present on benzene ring, they will also take part in the reaction. Because this primary benzylic, secondary benzylic reactions. This is a final order of the reaction which has been summarized on the present slide. Methyl is the last, phenyl is the in between, then it is vinyl where is double bond. This is primary, this is secondary, primary benzylic, primary allylic. This is tertiary, secondary benzylic, secondary allylic, tertiary benzylic, and tertiary allylic. Although this may not be possible that much, but yes, this. And the major fact for this substitutions and their stabilization is basically hyperconjugation. नाम ही कुछ ऐसा है, hyperconjugation. Generally, carbon can have 3 occupants or 4 single bonds. It is basically we use to term it as tetrahedral carbon. However, 4 से भी और ज्यादा conjugations है, bonding है, उसको बोलते हैं hyperconjugation. That hyperconjugation is observed in this case. ये 3 तो था ही खुद का तो bond, 3 के 4 bond तो थे ही, फिर भी they are trying to help out the carbon which is under tension. They are trying to help carbon which has less valency. And that is no more than carbocation. Second is the nature of nucleophile. That is irrespective because SN1 reaction does not depend upon this. The second most factor is the nature of living group. Just like in the last case, I give the example of a married couple, that if a wife has a good relationship with the husband, then this relation will be stronger. If wife has not a good relationship with the husband, there will be always fighting in between these two, and wife will not stay with the husband. He may get the divorce and went to his parents' home. Why? The stability of wife is more important for a husband. In other words, to make a strong relationship. So that wife can leave the husband of her parents' home and can stay with the husband. Living group के लिए भी ऐसा है. The same case which was applicable in SN2, it is also applicable in SN1. And after departure, if living group is stable, will be happy to leave the alkyl halide. If it is unstable, then will not be happy to leave the alkyl halide. It will be going back to the alkyl halide. The reversible reaction is possible. So now let us learn this thing. iodide ion, which can occupy the negative charge much easily because of the stronger, the bigger size. Iodide, bromide, chloride, and bromide or fluoride. They can occupy the negative charge. Hydroxide, RO minus, OH minus, NH2 minus, basically. These reactions all can be good condition. But generally, they does not deserve to good living group. The reason is poor basicity. So poor living group behavior is attributed. Sorry, poor living group of hydroxide ions can be attributed to OH minus, which is a strong base. Okay, so the last factor which is going to affect SN1 reaction is nature of the solvent. If you remember the last slides which we visited, where we learned the classification of the solvent, so we classified the solvents into these three types. Non-polar solvents, which have no polar functional groups. Examples, hydrocarbons, hexane, heptane, octane, nonane, cyclohexane, cycloheptane. They are non-polar functional groups. They have no polarity. Another functional group, another solvent is protic solvent, which contain OH and NH2. Functional groups can dissociate and can release the H plus ion proton. They are polar protic solvents, have polar functional groups. There are certain solvents which possess no functional groups. They do not possess OH or NH2, but they have polarity, but cannot release H plus. These are all protic solvents, polar protic solvents, can release H plus. वाटर में से H प्लस निकलेगा तो OH माइनस, मिथेनॉल में से मिथॉक्साइड, इसमें से निकलने के बाद इथॉक्साइड, एसिटिक एसिड में से निकलने के बाद एसिटेट आयन. All of them are polar protic solvent. Another solvent we visited, these are also protic. They are also polar solvent, but aprotic. They are not protic. I'm sorry. They are aprotic polar solvent. इसमें पोलैरिटी है, देखो इसमें अमाइड है, इसमें सल्फोन है, इसमें फास्फोरस ऑक्सीजन बॉन्ड है, इसमें अमाइड है. So they have polarity, right? They cannot release H plus ion. Hence, they can be termed as polar aprotic. The rate of SN2 reaction is faster with polar aprotic solvent because they can form hydrogen bond. SN2 उसमें था polar aprotic solvent because of hydrogen bond formation. But for SN1 reaction, the fastest is basically polar protic solvent. Why? Because if you see the mechanism, then the mechanism of SN1 reaction involves positively charged species, carbocation. And solvent, especially polar protic solvents, generally they release H plus. H plus ka plus or carbocation ka plus can have a friendship. Like dissolves like. ये जो carbocation है ना, that will be easily solubilized in polar protic solvent, easily able to solvate, and thus whatever the transition state is there, that will be easily stabilized. That will be able to help, I can say, this lowering of activation energy and accelerate the reaction. Non-polar solvents cannot do that much क्योंकि उसमें polarity ही नहीं है. इसीलिए this reaction is faster. You can see with ethane, you hide water as compared to some other reagents. See this case, dielectric constant, basically it is a measurement of polarity. Water is having an excellent dielectric constant, 80.4. H plus and OH minus are easy to separate. Hexane में से hydrogen निकालना मुश्किल है. C6H 14. That's why polarity जितना ज़्यादा उतना rate of the reaction भी ज़्यादा. These are some other solvents, hydroxy hexamethyl phosphoramide and this dimethyl sulfone. So where the rate of the reaction is faster. Dimethyl formamide, where again the rate of the reaction is faster. That is the case of SN1 reaction. So we'll stop up to this. We'll continue our discussion on substitution reactions in the coming lectures. With this, we'll stop ourselves. So